let me quickly go through some of the basics for networking. And so, to start with, we have to talk about why do we need networking and protocols. And I would like to really connect to the real world example of sending something to your friend, right? If you are sending a postcard, right? And so imagine, of course, you can send a postcard with just a message, and and you put that into the outbox, and the mailman is going to pick it up, and the whole USPS system hopefully will be able to find the destination and deliver for you, right? But there's also a whole mechanism of routing in there. But when you look at the postcard, there's a basic format to it. But when it comes to real communications, it's more than just going to be a postcard, because more often than not, you're going to send much larger chunks of data, right? Perhaps you want to send a whole article. And I would like to propose that perhaps you want to send, you're writing on a book, a novel, and you want to send the whole book, right? You're done and you want to send the whole book to your friend. But postcard is just not enough to hold the whole book. So you have to split the whole postcard into many postcards and one sentences at a time, right? So this is actually the same thing that happens on the internet, right? When you send something, it's not like the entire package will carry the whole thing to the destination. It's actually split that into packets and then will send over there, right? Now, when you drop all the maybe thousands of postcards for your novel, right? Think about this. You need a good mechanism so that when your friend receives your postcards, he or she will be able to put them together and then read it, right, in the order that you want. So first, a couple of things. It has to reach, of course, your friend. So there has to be some kind of formatting when it comes to the name of your friend, the destination, right, and then where it's from, right, from you. And so the from address should be there, and then the content of that particular chunk or section of your novel, right? And so the to address, right, the from address, right, or the destination and the source, the room, right, basically the payload, right, for one or two sentences on each card, and then sentences can be read by anyone, right? So assuming there's no encryption, right, everyone, again, postcard is the open text, right? So anyone can read. Now, the problem when you send all the postcards, depending on how USPS may be handling it, right? They may arrive at your friend's house at different times, right? And so even though some sections or some chunks you may send later, maybe they will arrive early, right? So there's no guarantee that they are going to arrive in the same order in which you send them out. And so how can we make sure, okay, that your friend will be able to put them back together in the right order? So it's not just the to and from address. It's not just the number of sentences, but you also have to agree on the coded number, right? So that like, okay, this is number one, this is number two, this is number three, right? So there are a lot, and perhaps you have a specific structure in terms of chapter number and sentence number. Maybe that will make it even easier for your friend to put things back together. So this is the whole notion of the protocol, right? When it comes to the formatting, right? So a big part of a protocol is the format in which that communication is structured, right? This is number one. Another part of it is the sequence. Okay, so think about when you just simple greeting in the morning, right? When you see your friend in the hallway and you say hi, and friend say hi back, right? And then you go from there, like, what time is it? So there is a sequence of this communication, right? And so in this example, you feel like, okay, maybe there is a high and high back normally is more almost like an introduction or handshake, right? You establish the connection, right? Otherwise, like your friend may look the other way and then you ask, what time is it? No one's going to respond to you. So this is handshaking, establish the connection, and then you communicate, right? So that is also part of the protocol, right? You should specify so that communication can proceed. And that is actually exactly what happens on the internet when these protocols. You need to establish a connection request, and then the request will be granted, right, by the server or the other party, and you can proceed to say, send me this file. I want to read this file. I want to download, access this file. Right? So that is the protocol. So the term protocol refers to a well-known set of rules or formats to be used in order to perform a task, right? A task of communication, in our case, between the different processes, right? Computer processes. So there are different parts, and which I outlined earlier, right? The first part I say is the format, right? In which format the data should appear, right? Or the message should be formatted so that it can be decoded, right? And then the specification about the sequence, right, of messages that must be exchanged in order for this to happen. So both parts are very important, otherwise you just cannot communicate. And so existence of a protocol, a standard protocol, will enable separate components of distributed system to be developed independently in different languages and on different platforms. And what exactly happens, right, on the internet, on the web. Think about all the different programming languages that we have, not to mention the different hardware, right, and operating systems that we have in place, regardless whether it's Microsoft or Apple, Google or Amazon, right, Python or Java or JavaScript, doesn't matter, right? As long as you communicate in that same protocol, it's going to work, right? Later in the class, we are going to look at examples of JSON, and then Python can process JSON, right? React can process JSON, right? PHP can process JSON, right? jQuery can process JSON. And next week, maybe we'll talk about Node.js on the server side. It can also process JSON, right? So all these different languages and frameworks and libraries, as long as you establish the protocol, right, you can communicate. And so there are 4 basic elements of a protocol, right? These are a set of rules governing the communication between 2 peer entities. And it all boils down to these 4 elements. One is a syntax or the format, right? So if you say, okay, this is kind of an example of HTTP, right? If you want something, you want to access something, use GET, and then tell me which file, and also tell me which specific scheme or protocol or version of it that you are using in this communication, right? So that is syntax, and then there's semantics, which is about what it means, right? This means, right, there's an interpretation of this GET request, which is to access that file. And then following that, there should be some kind of action, right? Upon the receipt of this particular request, what should the server do, right? What should the other party do, right? If someone asks you, what time is it? Right? You should respond with the time. Whether the time is accurate or not is the second question, right? But you should respond to that request, right? And so that's the action. And of course, there is also timing. And this really depends on, the nature of the protocol and the particular task that you try to implement. Traditionally, it's more of a kind of a synchronous order, right? You process the first request and then the second and the third in that order. But this is kind of blocking, right? If sometimes you do have to use this some protocol if your task depends on another. Like you have to finish the first one, before the second. In that case, one has to become before the other. In others, maybe it's not necessary, right? So now lots of programming and what you do for web development and for web mobile development, a lot of it is non-blocking. You should have this in mind. Like, when I send this like Facebook or Twitter, right, there are lots of components of interface. This portion of the interface should be updated when there's a request to the server and get a result back. This should be an independent process to the other and should not block, right, the status and the updating mechanism of the other. So these non-blocking mechanisms or asynchronous communications are very common today. But again, timing, the relative order of messages should be part of it. So the internet protocol is really very complex because it takes so many different components and there are so many things, right? So think about just a simple communication of sending a message from one computer to the other, right? It actually goes through from your computer if you are accessing, for example, a football club in England, right? So that club website is in a different continent. And so when you send a request, it actually goes through a number of servers and routers, right, in order to reach that destination. So like you will have to, of course, go through the routers, like the gateways at Drexel, right, potentially to Penn, and then from Penn to other backbones of the internet, and then maybe the cross-continental, the fiber line that connect the two countries together. So lots of different machines and routers in between, right? And so it's a really complex process, and because it's complex, there are so many different things to consider, and there are many pieces, right? So when we communicate, think about this. You have your Mac. Some people have their iPhone or Microsoft or Android, right? So different devices, right? So there are different types of media, hardware and software. But media is also important because traditionally we use the wire connection. Now it's wireless, right? And then there are routers from Drexel, from Penn, from different organizations. And there are hosts that you may visit, right, from different places as well. And then there are different applications. Now, lots of it is on the web, but it can also be, many of us are doing today, like video conferencing or gaming, right? So different applications, and their requirements are really different. On the web, you send a request, and the page comes back a second later. It doesn't make a difference. But if you are doing gaming, think about it, the lagging. Sometimes my son is truly frustrated. Like, there's so much lagging. But to me, no difference. But but depends on the application. It's the kind of the lagging, or what's the term, latency, right, is truly important. And so, with so many in place, in question, how can you put all these together, but also allow different types of media, hardware, software to be accommodated? So is there any hope of organizing the structure of network, right? So, dealing with these complex systems, we need to have a proper way to layer these different. So basically, we need to construct, have a structure, right, that allows identification, relationship of complex systems pieces. And so this is a very classic approach to create a reference model, a layered reference model for this discussion. So in that light, let me summarize the basic idea here is that when you create different layers, it's going to make it easier to create modules for these layers that can work together instead of create one big piece with all these complexities, right? So that those hardware manufacturers can focus on the hardware layer, right? For us, who are more focused on the application, we can focus on the application layer, right? And so we can kind of truly polish our expertise and work together. And so the OSI reference model is the internationally standardized network architecture. And this model has 7 layers. And of course, this is an abstract layer. The actual number of layers actually implemented in the current internet, there's a debate about it, but I mean, between 5 to 6 layers is a common reference system. But according to OSI, these are the number of layers in place. So the physical layer, obviously, down to the wire, right? Basically, it's a wireless or wire with a frequency, right? So this is the physical layer, and then data link layer, right, which is on top of the physical, almost very close to it. And then there's networking to route the different pieces of packet to one another, and then transport, session, presentation, and application. Now, some of these, like application and presentation, normally people will talk about them as one layer. And so there can be either from 7 layers or 5 layers. Okay, so it depends on which model but layering in general is a good thing because it allows you to look at different layers and be able to focus on one to improve it. Or another way to think about it is that now we have all the different layers of implementation. Like at the top is our application layer for the web, for gaming, for different applications, and so that is done, right? People have done lots of work in there. Now, around year 2000, early 2000, that's when wireless, Wi-Fi became more popular. Before that, it was all wire connection, Ethernet. So when they transitioned from wire connection, right, to wireless connection, you can basically swap out, right? Just change this, re-implement this physical layer without affecting the other layers. So the web continue to function, the whole internet continue to function, even though we have changed drastically, right, from kind of wired Ethernet connections to Wi-Fi connections, to mobile connections, right? It doesn't affect the other layers. And that is the beauty, and that is the advantage of this layer model. Okay, so I said you can look at it as 7 layers, or some, to simplify it, we can look at that as 5 major layers. Okay, at the top, application, and then transport. Application is really, as the name suggests, just for that specific application, the top level. Okay, whether it's for the web, which is HTTP, or if you see SMTP, which is for email, right, to send out emails, FTP to transfer your files. Okay, so these are different applications needing different types of, protocols, and then transport is the process to process data transfer. Okay, to make sure that either data can be transferred securely and consistently, or to make sure that it's efficiently transferred from one place to the other. And then there's networking layer, which determines the routing of the datagram from source to destination. The link is the mechanism to kind of connect neighboring network elements together. So link is when you are here, right, within this room, within this local network, that is what is the most important for your computers to talk to one another. Okay, and then the physical layer is on the wire, the bits really on the wire. It's physical. So, and this is just another depiction of it, right? So when one computer, when we say host, you can just think of it as one computer, okay? When one host communicates with the other, you have to go through all these layers, right? When you send an HTTP protocol message, you send a kind of an HTTP request, right? That request will all go all the way down from application all the way to the physical, because until you can reach the physical level, it cannot be really sent, right? It's that, and then when it reaches the destination, it has to be decoded all the way, right, to the application layer. Okay, so let's look at specifically how does a web browser retrieve data from a web server. And in this case, we're looking at the Hypertext Transfer Protocol, HTTP. And of course, a more common version of HTTP is the HTTPS, right? The secure HTTP, but the essence of it is still the same, right? So the user invoke that application, which speak by speaking that application protocol, right? And then the applications will interact with that protocol to send or receive messages. So let's look at one example of it, right? So if you go to a website, and I think later today, actually, we are going to test this particular box. It's called www.cs.drexel.edu. Even though it was traditionally named CS, now it's a college-wide service that all students at CCI will have an account on it. And you can also make it a website for you. And it supports PHP. So out of the box without any configuration. And that's why I think it's easier for us just to test it this out of the box later today. Has any of you used this server? No? Ever? I'm surprised. I thought everyone is using it. Okay, but we're going to give it a try. The setup should be rather simple. Yes?
For like Tux or something like that?
Tux, yeah, that is Tux server.
Oh, okay, yeah, maybe I'm using one.
Yeah. So, but Tux can be used for so many different purposes. It's a very general purpose server, but you can also, under your home directory on Tux, you can make it a web. You can make a web page there. You can also make a PHP page and connect to the database and make a whole full application out of it. Okay, so that's a possibility. But anyway, so this is a page, just like any page can be your page, right, on this Tux server. And if you are testing it on your browser, right, you are essentially sending a request. Okay, so when you type in the URL, you essentially send a request, a GET request. Okay, I should say your browser on your behalf is sending a GET request, okay, to this host. Of course, computer also has to figure out where this host is by using the DNS or the domain name server to find out, okay, which IP, right? Because IP is the actual address. And so once that is figured out, it's going to send this GET request. So GET and then the path name of the page, right? And then the scheme, which is HTTP/1.1, HTTP version 1.1, and then at this particular host, right? You may ask, like, why do I also have to provide a host? Because I'm already sending the request to the host. The reason is because on the same IP server, you can host it can have multiple hosts, okay? And so it may host www.cs.drexel.edu. It may also host cci.drexel.edu, right? So on the same server, you can have multiple hosts. So when you send a request, you also have to make sure that, and this is part of the HTTP protocol, so you are guaranteed to make sure to send which host, okay, this particular file should come from, okay? And so when this is sent, right, at the application there, this is what you see, right? The HTTP message is the GET request. Now, as I said, it has to go down on the layer, right? So application to the transport, right? That provides the end-to-end communication between applications, right? And so that will divide the stream of application messages into packets. Because sometimes maybe your data is so large, right? It cannot be sent in one. Maybe it could, but it takes more time to verify, right? So it makes sense to break down and send them in packets, okay? And so, and this transport protocol layer will make sure that the data will be sent in a reliable or unreliable way. And you may wonder, like, why do I want to send this in an unreliable way? Because again, it depends on the application, right? If you want to send really an important like email, right? You don't, or something that is SOS, right? You don't want to send that in an unreliable way. So the TCP protocol is probably what you have to rely on. On the other hand, it's with video conferencing and you are sending some pixels, okay, over it. Maybe UDP is something that you want to use because that is less reliable, but it's more efficient, and because you care perhaps less latency than accuracy, right? You will miss a couple of pixels. I may not see that person that clearly, but there's less latency, so I can respond faster, right? So you can decide. But there is basically a decision between the TCP, which is more reliable, versus UDP, okay? And a couple of other considerations. So there is a transport layer. So when that is down into the transport layer, you will see there's a source, there's a destination, and there's also a checksum, right? So that things can be verified, and this will be encapsulated, right, as part of the lower layer protocol, okay? And then now, with that protocol, making sure data can be sent reliably or unreliably, you still need to figure out how that can reach the destination, right? So the analogy is like, okay, here you write that down on, so the transfer protocol is more like you write it down on paper with the ink, right? Or with a different marker, right? And so that the ink would be kind of very clear, and when it arrives at the destination, that will guarantee readable. Okay, I'm using an analogy, so don't hold me accountable for that. So, but still, from the source to the destination, you have to go through like, okay, I'm sending a postcard, right, from my house to my friend in England or in India, right? It has to go through many different phases, at least two postal systems, right? The USPS in this country, and maybe the Indian, right, post office. And so how do they communicate to one another to guarantee that it will reach the destination and things in between? So it's a very sophisticated mechanism, and that is the layer of this internet layer responsible for, and the keyword is routing the communication between one machine and the other. Okay, so internet protocol, IP protocol, encapsulates packets in IP datagram with IP header and uses routing algorithm to decide whether to send directly or indirectly, and most often this is going to be indirectly. Okay, and so this routing algorithm is key, because this routing algorithm is a distributed algorithm, right? There's no one guy that is like directing everything. It's working together. Again, think about, when I send out something to Drexel server router and Drexel router send to Penn's router to others, right? They have to work together. And there's no, like, I'm the boss, I command you to do something, there's no such thing. We just work together as co-workers, okay, on the way. So it's rather interesting. So now it goes down to the internet layer, and of course, the important part is the IP address, right? Because ultimately, that is your home address, just the source, the from address, and the to address, right? You have to make sure that it can be delivered, it will be delivered, right? So that is the IP, and then of course, when it reaches the local area, to the local community, that is when this network interface layer comes in. When the packet reaches this room or this building or CCI cluster, then we have the network interface layer that transferred over specific networks. So maybe that's just for the sake of discussion, this is a whole Microsoft network, and so we know the way to figure out how to send and connect within this network. Okay? So that is the network interface. And so within the network interface, you see these numbers. These are we call them MAC address. Okay? So the MAC address is like, these are burned in addresses on your adapter card, whether on your Wi-Fi adapter, or if you use wire, your Ethernet card adapter, okay, that allows you to communicate. Okay, so this is kind of the local area network communication. And when you reach this area, very important, there are going to be, of course, you will be able to specifically talk to a particular machine on a particular port. And ports are destination points within a host computer, because one computer will communicate, right, with many parties and from many processes, right? So on the computer, you probably have an email system, right, browser system. They're going to talk on different ports, right? So different processes run on different ports, and so that if the different process, you know, it's on a different port, so you can talk to the different port differently, right? So these are all part of the protocol. Let's see, I can skip some of these, and this essentially captures some of the idea. I will just let it run from the source. When you start with the application level HTTP get message, is to go down all the way, right? And on each layer, it will add a header to encapsulate the message. Okay, so from a message to a segment at the transport layer, and then to a datagram at the network layer, right? To a frame in the link layer when you talk locally, to the physical bits, okay? And that is sent first to your gateway, to your switch locally, and then they'll find a way to communicate globally to other places. And then when they reach that local community again, all these will be decoded in a sense, right? So remove the headers, and it will go up, right, from the low layer all the way to the upper layer, to the application, and the message will be received. Okay, and that is when this message will be received. And so if it's a GET, right, request, that server, maybe this is ultimately a server in a different country having a web page that you're interested in reading, right? So it will get this GET request, right, for that particular web page, and will start the process to respond to this message. Okay, when that is done, of course, it starts another cycle of sending the response back. I think for some of these, I can just quickly skim through. We don't need to talk about all the history of how this come into being, but it's really started with the military research experiment in ARPANET. And Internet, as we know it, is a network of networks, and the whole mechanism of communication takes lots of routing in between. It's a distributed mechanism. And of course, when it's a distributing mechanism, there are lots of ways where you may interconnect. So lots of different ways or topologies of connecting all the peers together. And so I think what we end up with is something more like this, right? So we all have like ISPs to connect into, right? And then there are ISPs in different regions, from clusters and then into a global network. So it's really indeed a network of networks. And so some facts about Drexel internet connections, I don't think we need to spend too much time because our purpose here is really just to understand how this whole thing works and then zoom in on the HTTP protocol. And so again, these are some details regarding IPv4 versus IPv6. Again, we don't need to spend too much time there. Okay, so the key ideas here is really networking, right? It's similar, right, to sending routing postcards. Think about that. And there are different layers dealing with different problems, right? So application layer is really just the application. If you are writing a novel and you have an application to send a novel to or a book to your friend. And then at the physical layer, it can be that piece of paper that is being carried around by your mailman, their trucks and system, right, to reach the destination. Let's see, local area, and there are, so I think just one thing is that the real address, of course, on the internet is the IP address, right? And IPv4, as we know it, we ran out of IP address for IPv4 many years ago. And some years ago, we started facing IPv6. So all of our current network interfaces can support, IPv6, IPv4, so. And interestingly, when they originally designed IPv4, they thought, we are going to have enough addresses for everyone. But before they realized, we ran out of addresses. And so I think IPv6, they try to be more ambitious. They say, we want to even give each atom an address. That's what they try to do. Hopefully this is enough. Okay, so for sure, anything in your refrigerator can be a heaven. It should be enough for an apple in your refrigerator to have an address, for sure. Okay, but these are the addresses, and they are routers in the whole system to help relay. So routers more like the mailman or the truck drivers. Okay, they connect to one another to deliver for you. Security, for now, we don't need to get to security. I do want to talk about part of security, maybe week 8 or week 9, when we get into more integration. And there are going to be considerations when your app try to integrate, when you have layers in your application, not just the front end, the UI, but also the business logic, which you may implement as part of the server-side scripting, whether it's PHP or Python or Node.js, and then that connects your database with database, either SQL or NoSQL integration. There is going to be security concerns. And we'll talk about some of the related challenges and techniques when we get there. So that is kind of a very brief overview of networking. And then the next I'm going to get into is more HTTP focus. Any questions so far regarding networking in general? Let me try to open my second slide, which is, I believe, HTTP. Yeah, that is the next topic. So we're going to zoom in on HTTP and then from HTTP to JSON APIs. So I hope this makes sense. It's kind of zoom in on what we want to achieve. But I think it helps to have a big picture first. So there are different protocols that as we know, right? And these protocols can run on different ports and systems, right? And so just to name a few protocols. So this is the 7-layer according to OSI reference system, right? So look at the physical layer, right? Wireless. You probably have seen some of these, right? And then Internet. These are really the physical layer, right? Because there's a radio frequency channel associated with that, and then go up, you have the IP, V4, V6, responsible for routing and addressing the hosts, right? And then transport, primarily between TCP and UDP. TCP is more controlled, right? Control, so it's more reliable. UDP is like more user-friendly and less reliable, so to speak. Okay. And then application layer, you have all these. There are many more, right? But nowadays, there are lots of applications are based on HTTP. Even emailing, like Gmail, right? The whole system of Gmail, a lot of it is actually on HTTP. So HTTP now is really big. And even sending files. Right? FTP was designed for file transfer, okay, but not for use HTTP for lots of file transfer. Right? So because it's so straightforward to use it, because everyone is using the web, and today, I mean, sometimes I have to clarify. Conceptually speaking, the internet is not the web. The web is not the internet. But usually people would use it interchangeably, right? Because it makes sense. Lots of what we do on the internet is on the web. So this is just an example of, when you send a GET request to request a web page, this is actually what you see on this tool called Wireshark, okay, which is kind of a sniffing tool, allow you to look at what actually happens on your network interface. Okay, and so again, it's multiple layers in there. So I'm going to get to an example. Okay, so I'm going to skip some of these risks and vulnerabilities, but just to and this is something we are not going to try on, but I definitely encourage you to try. It will be lots of fun. This service will actually allow you to explore lots of web services that you may not have heard of, but they are out there, okay, like on Drexel campus. So to imagine what are the sensors and services that you can access, right? Even the temperature or whatever sensor on a boiler somewhere in a chemistry or engineering building, and you can actually search and find those, and then use your web HTTP protocol to interact with them. Okay. Of course, some are behind, like you have to get authentication authorized to do so. Some are just open. Okay. But there are so many services and protocol, and Shodan is a service that scans the entire internet and passes, banners and return the various devices. Okay, so that it exposes basically the different servers in existence, and there are many different industrial protocols, and many of them today are on top of HTTP. Okay, you can see they are based on web services. Or your printers and things like that. So, I mean, when you get to the website, you can explore the different protocols in there. Okay, so this is something, So, if you know, okay, certain like for webcams, if the industrial standard is to run those services on a particular port, you can go to Shutdown and search on that port. And you can also limit that search to Drexel CPU. So that would discover all those devices and services within the Drexel domain that may be related to the webcams and printers and among other services available on this campus. Okay, so you can scan. I believe. Do I have example of? Yeah, so this is definitely something on Drexel campus. It's part of the Drexel University. It's part of the chemistry. Right? And hopefully I have additional slides. Actually, I don't. Yeah, I did not take all the slides. Put it here. Some of the screenshots I missed, but but these services can be part of the basic facilities on Drexel campus. And when you click on it, you can get into it and see what they are, okay, and how to kind of communicate with them. Okay, so that is the kind of the different type of protocols that are potentially available. So these are things that I have gone through. Okay, just some of the, and this is the kind of another picture to look at the data encapsulation. Okay, so again on the application layer, you want to get a page, and then this is what happens when the header is added in the transport layer, and then on the internet layer you have the IP addresses, and then on the network layer you have the actual burn-in MAC addresses, among other things, right? So there's encapsulation. Now let's really get to the web. Okay, so talking about the web, of course, there's a name that we have to recognize, right? Sir Tim Berners-Lee, right? He worked as a scientist at what's the name for it? It's the European Nuclear Research Center. I don't remember the name, but he was working at that facility, and his original idea for the web was to create a system so that you can reference different scientific publications, and for scientists to share the results with one another and link with each other. So it's really to facilitate scientific communications, particularly in the nuclear, in the high energy physics, but of course this became such a groundbreaking idea, and Tim Berners-Lee is also an engineer, and he implemented the original web server, and he put his first page up there. This was about 1991 or 1992, right? So it's a simple stateless request response web protocol that did not require a persistent connection. So the idea was very simple. I put the page there. Anyone can send a request to get the page. Right? That's it. And of course, over time, there are more functionality to the web protocol. And so there's a mean inside this protocol to locate a unique address, which is URL, the protocol for the transfer of the messages, and then a markup language for the creation and structure of of the content. So we know HTTP is really the protocol that allows the fetching of resources such as HTML documents. Of course, nowadays in modern web HTML document, you can fetch anything in HTTP, even videos, right? So, and I mean, these are technologies, especially those on top, right? Most of these you should have good exposure to by far, right? HTML, CSS, and JavaScript. This is the web layer. And then, of course, this is on top of the additional internet layers that we discussed earlier. But you see that this is also how this is structured. You see the web API, right? The application programming interface is on top of JavaScript. Because lots of it now is based on the JavaScript object notation or JSON format. Okay, so I think we already talked about this, so I don't need to, but let's also have a breakdown. Just make sure that we all understand what a URL entails. When we use APIs, these components should be very important to understand. Right? So when you just put the address there, of course by default this is the HTTP colon / a double slash, right? So that HTTP or HTTPS, that is the protocol, that is the scheme, right, of the communication, followed by refer to it as a domain name, but more generally as the host, right? It can be the name, can be the IP of the server being accessed. And then the third, okay, which we kind of skip, because by default, if I do not specify, and for HTTP port 80, okay, the default port, okay, but if that service or that page is on a different port, okay, if the web server runs on a different port, then I need to use colon and then the port number. Okay, for example, 8090, okay, can be the port. And then followed by the path, right? The path. So this is the sound department right? So that is kind of the reference to the specific file and where the file is on the system. But this is actually not done yet. There are still things after the file name, right? And especially when we get into APIs and also RESTful, and we're going to talk about this notion of RESTful APIs. So you're going to have parameters when you access these APIs, and it depends on how to design it. You can use URL parameters to identify, right, things, right, query string that can add additional, variables or even data to your request, right? So, and an anchor with this hash mark, right? So there's more to it as part of the URL, okay? So again, when I encounter something that we have discussed earlier, I'm going to just quickly skip. And so So when it comes to communication in HTTP, right? So when you type in something in the location box of your browser, or either by clicking on the link, right? That is going to send a GET request, GET, and then that target web page URL to the server, right? And then the server, once it receives that request, it's going to process the request. If it's a GET request, it's going to find the file that is requested and then read it. And of course, if that is successful, right, it's going to send content of the file, particularly a web page, back, right? So that page, the content obviously will be sent back, but there will also be header, metadata regarding what the page is, right? What kind of content type is it? How long is the page? Among other things. Okay, so that is one cycle of this HTTP request response communication. Okay, so so this communication you can kind of liken it to sending an email to someone and then someone sends you a reply, right? It's kind of a message and reply, message and reply. And the original version of HTTP is stateless because it does not monitor the state. Like when you send a request, you will establish a connection with the server, send the request, and get a response back. The connection is first, then there's no trace. Okay. Right. In the original design. Okay, so next time you go back to the server don't remember. It doesn't remember who you are. Okay. And so of course later will come up some way to provide a code plan, like a cookie, right? So that the server will be able to recognize, oh, it's you again, I know you. So I will be able to, okay, we can skip all this communication and go directly to, but original design is stateless, so, you have to, so every transaction, every communication is independent, okay? Let's see, so these are, okay, so again, just and this is really important because when you are API, you develop API, they integrate, you really need to understand these, okay? Whether to test, to debug, right, to figure out things, so GET is the method, right? When you send as part of the HTTP, this is in the HTTP protocol, right? GET and then slash is a path, of course. This slash is, but it can be slash and then path slash file, right? So depending on where the file is, this is the reference to the file, and then the scheme or the version of the protocol. And then secondly, in the second line, the GET request is the host, which host should the file come from, and then there can be other things such as what language to accept, right? Things like that. So that is the HTTP request, and then this is kind of a longer version of that request, okay? And then let's see. So this is another version. Let me see. This is still this is another message which posts. Okay, so just now it was a GET. Right, GET is a very common mechanism. If you want to just access some page, GET is the most common request. Okay, GET can also allow you to post some data, but there is a kind of a tight limit to it. Of course, with current standard, it's a lot of data. But post is a more general mechanism designed to when you want to send data, a lot of data to the server. Okay, so when you want to send some lot of data to a particular process on the server, this is what is traditionally done. Okay, you send a post, okay, and of course followed by again in the HTTP protocol, right? You have to provide what is the host again, the content type and the other things we discussed, right? And then at the end of it, because it's post, right? Suppose you need to provide data, so this XML, right, is the piece of data that you can provide. Like, okay, this is my data. Take it and save it to the database, something like that. You can send the data. Of course, this piece of data most likely in today's context will be JSON. Okay, because I mean many years ago XML was big, and people use XML, and now it's JSON. Because I think the beauty of JSON is that it's easier to read, okay, and also easy to parse from. So for humans are happy and machines are also happy, so why not? And I guess that is a reason for the popularity of JSON format, okay. So of course there are other HTTP methods such as put and delete, but these are, I should say, they were all part of the HTTP protocol, but they are less used. Okay, not as like get and post. Like when you design or use APIs, then get and post is 99% okay, of what you will be using. Okay. Occasionally, they can be put and delete. Okay. So, and then, of course, when we talk about request, we have to take a look at the response, right? So we send a get request to request a page, and of course, in the end, the server should send us something back, right? So if we want to access the page, please send us the page content back. And so when it's sent back again, it follows the same protocol, and again, so it says this is communicated in the HTTP protocol 1.1, and then followed by a status code. And 200 is that everything is okay. It is available to you. Here you are. Right? Over time, you see 404, which is not found. Right? So there is all this of code that you can reference and status messages to say okay. Right? And then along with some metadata, date, server, whatever, right? So header information, and then in the end, if there's content, there should also be content, right? And then the length of the content, among other things, and the actual content on the world, right? In HTML. So that is the whole HTTP, and that completes one cycle of HTTP communication. You open a connection, send a GET request. The server processes the request, send the response back, right, with the content, and that's it, right? So in this way, web servers and browsers exchange information using HTTP, and web servers are often called HTTP servers, and web browsers are sometimes referred to as HTTP clients. And today, I wonder what you are using, right? And what do you use? Safari is your favorite. How about you?
Great.
Which one?
Great.
Oh, I have never
Heard of it?
no. What did you put for?
Fun.
Like, why did you use it?
Because it loves bags.
Okay, okay, cool. Probably I heard of it, but it's never used it. You know that? The same? Okay. Makes sense. The same.
So what, right? Safari.
Safari, okay. So because you're on Mac. Okay. Okay. Yeah, my favorite is Chrome. Some years ago it was Firefox, and then Firefox was a bit behind, and then Chrome. Of course, I did not really use Microsoft IE, but nowadays I think Edge is actually catching up, Edge is doing much better than IE is like too much legacy for so many years, and they just couldn't get rid of certain things. But Edge is a new creation because I think it's based on the same code base as Chrome, so it had a much better starting point. But anyway, of course, we are all using different browsers, many mainstream browsers that we rely on, right? So these are HTTP clients, right, that enable us to access, right, a variety of content using HTTP protocols on the web, right? So no need to talk about proxies at this point. Stateful, hopefully we'll talk more about stateful, stateless next week, but I want to quickly share something between the difference between HTTP 1.0 and HTTP 2, because 2 is really kind of current and future, but lots of it is still on HTTP 1.1, which has been used for so many years. Like 1.1 was what I was using 20 years ago in the industry. And I couldn't believe it's still 1.1, which also says lots of good things about it. Like, this is so good that people just couldn't get rid of it. Okay, but of course it can be improved. And so let me show you just a good thing. So 1.0 is kind of the original, and it was part of Tim Berners-Lee's design, and then 1.1 was further improved around about 10 years later, and you can see this timing is important because this is also the time the .com, right? The internet started to attract attention from ordinary people, okay? And people get invested in there. I remember Google 1998 started as a search engine. The company I work for, Lycos, 1994. Okay, they started as a research project at CMU, and then they commercialized. So again, all those internet companies, they got a lot of investment back then. So this was an important time. So we defined the protocol. Okay, 1997, and then HTTP2. This is RFC specification, but it's still not yet fully supported. Okay, but let me just using one picture to capture the core idea of HTTP2. Like HTTP1 or 1.1, the idea is like each resource requires a separate request. Okay, remember you always have to create your web pages. In the web page, you link to your CSS, right? In the web page, you embed an image. In the web page, you also perhaps link to your JavaScript, right? When the page is loaded in your browser and you go to the backend, I'm sure you have done so, right? There's a request to get the page. There's a request to get the CSS. If you have 10 CSS files, it's going to send 10 requests. And then, depending on how many images you have, there are also that number of requests for the images. And so it's going to slow down. There's a lot of overhead, right? So it's like this. You order something and they don't bring the items, the food to you at once. They just, when something is ready, they give it to you, which is maybe a good thing. Like, great, right? When it's ready, just give it to me. So it doesn't block. But HTTP2 essentially is trying to reduce the latency for sure, but trying to give you as fast as possible, but everything in one request. Okay, so this is HTTP1. So every time, like all the different items that link from one page, every time you have to establish a connection, send a request, get an item back, let's say, okay, the page back. Establish a connection for the HTML page. Get the page back, close the connection. Send a request for the CSS. get the content back, close the connection, and then JavaScript the same thing, images the same thing, lots of overhead. HTTP 1.1, at least from the connection point of view, you can just open one connection and then send multiple requests, response in between. So that's faster, right? At least you don't repeat the connection because the cross connection is costly. Okay, now HTTP 2 is like everything can happen in parallel, okay, asynchronous. So ideally this will be better. Hopefully some version of it will gradually be implemented in the browsers. I mean, sometimes Google went ahead to implement some version of what they wanted, but it may not be widely supported. Okay, I know Gmail, like part of it has used some kind of Google's own version of, if you run it on the Chrome, it's going to behave slightly differently from the efficiency point of view compared to other browsers. Okay, so HTTP 2 is the future, but HTTP 1.1 is still where we are. Okay, after more than 2 decades of since it was introduced.